Hello, and welcome to the lecture on main effects and factorial designs and interactions. Let's get started. Factorial designs and interactions deal with multivariate studies. What that means is that we have multiple independent variables and or, it could be either or, multiple dependent variables. So this can be any combination of one independent variable and several dependent variables, multiple independents and a single dependent, or multiple independent variables and multiple dependent variables. Multivariate just works that you have more than one for either or the independent or dependent variable. Multivariate. So with multiple dependent variables, we can be looking at different types of effects. So for one, you can be measuring the same construct in different ways. We talked about self-report, behavioral, and physiological operational definitions of a dependent variable. Keep in mind that if you have a multivariate study looking at stress, let's say, as your dependent variable, you can have a self-report measure of stress saying like, oh, in the last 2 weeks, indicate which of these applies to you, and there's a series of however many statements. That could be one. Another can be measuring cortisol levels, which would be a physiological operational definition. And we could also be measuring stress through behavioral measures of like how often you pick your nails or fidget or something like that. So we can have the dependent variable can be measuring the same construct like stress in multiple ways through cortisol levels, a survey, and then counting how many times you're biting your nails. However, when it comes to measuring multiple dependent variables, it comes into play when we have these carryover effects. Keep in mind that when we talked about within subjects design, where one person takes part in all the conditions of a particular independent variable, there were issues of the fatigue effect where you get bored or tired of doing the same thing over and over again, so your performance might suffer. You have the practice effect where it's kind of the opposite of the fatigue effect. You do something over and over again, you get better at it, so your performance actually improves. And then we have the context effect where based on your responses or the exposure to one variable, to one condition of the independent variable, it can alter how you react to the second condition. Now, with that being said, that's also the case with dependent variables when we measure them, when we have multiple dependent variables to measure. So we do have the same issue of it's possible to have carryover effects, fatigue effects, or context effects. Again, the same carryover effects that we have within subjects design, because our participants are dealing with they have to measure stress through a self-report measure, through behavioral measures, and physiological measures, or whatever that dependent variable might be. So when it comes to controlling for these carryover effects, we do the same things that we would do for within subjects design, where we randomize the order that participants are doing them. So we're randomizing the order that you take your stress, the multiple measures of stress. So maybe some people start with the cortisol levels, other people might start with the behavioral measure of counting how many times they fidget or whatever, and then other people could start with the self-report measure, the survey, and then randomize it from there. Now, multiple independent variables, again, the independent variable is what we, the researchers, are manipulating. So that's what we're thinking is going to cause a change in the dependent variable. So when we have more than one of these things that we're manipulating in a study, it makes it more efficient. We don't have to conduct as many studies. Maybe we're looking at the scores between a math test and an English test and comparing the average. And then we're also comparing, a loud room and a quiet room, and we're comparing. Well, those would be two separate studies, loud room and quiet room, taking an exam, comparing the test scores. But hey, why don't we just put them together, make it one study? Then instead of having to do two separate studies, we have both of our independent variables of the test type, be it English or math, and the room environment, quiet or loud, Both of those are being tested at once. So it's convenient, it makes it more efficient, we don't have to conduct as many studies. However, with that, with having multiple independent variables in any sort of study, it brings along the concept of interactions happening. And I'll talk about interactions. So factorial design, again, we have multiple independent variables. Now with this, we have multiple conditions. So let's say we talk about that one example that I had of having people taking a math or an English test. That's a manipulation we've made. You either take the English test or the math test. And we also have, so that independent variable has math and English, so 2 conditions. And then we have the independent variable of room condition, either quiet or loud. So we have 2 independent variables and each have 2 conditions, math, English, quiet, loud. With test type, math and English, test condition, or like room environment, loud or quiet. So we have a 2x2 factorial design. The 2 that we state is indicating how many conditions are in an independent variable. And the fact that it's 2x2, there's 2 separate numbers, indicates there are 2 independent variables. Now, in order to indicate how many conditions that we have, we would just multiply 2 times 2. So we would have 4 total conditions with our study of having the independent variables of taking a math or an English test, and then a quiet or loud condition. You know, we have some people taking the math test in a quiet room, other people taking the math test in a noisy room. So that's 2. We have some people taking the English test in a quiet room and some people taking the English test in a noisy room. So we have 4 total conditions for that. We're just multiplying. So when we have this example here, the 2x2x2, that's telling us that there are 3 independent variables because there are 3 numbers, a 2x2x2. And the 2's indicate the conditions. So first independent variable has 2 conditions, the second independent variable has 2 conditions, and the third independent variable has 2 conditions. So in order to indicate how many total conditions there are, we would just multiply 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So that factorial design of a 2x2x2 would have 8 possible conditions that participants can be placed in. Now, this can be a combination of a mixed, within, or a between subjects factorial design. Again, factorial. Between subjects, 1 person, 1 condition. So we have 8 total conditions in this particular example here. So 1 participant is only in one of those 8 conditions. For a mixed within subjects design, 1 person is in all 8 of the conditions. And for a mixed subject, some people, maybe it's half and half. Maybe half of them take 4 of the conditions, the other take the other 4. So here's some examples of kind of seeing the conditions and just kind of what they look like when they're graphed. So this bar graph up here is a 2x2 factorial design with our independent variables being cell phone usage and the time of day. So with it being a 2x2 factorial design, we know that there are 2 independent variables as stated as cell phone usage and time of day. And there are 4 total possible conditions. And you can see that by the 4 different bars in this graph here. So we have the independent variable of time of day on the x-axis of day or night, and then the dependent variable, and then the other independent variable listed as these different colors for the graphs. So blue is the no cell phone, and red-ish is the cell phone usage. So we are looking at the driving performance as the dependent variable. We see that in the y-axis. And so we're looking at this example, and we'll see that there are 4 conditions. You're either using your cell phone during the day, or you're using it during the day, or you're not with the blue, or you're using it at night, or you're not with the blue again. So we have 4 different bars, each indicating the different condition you can be in. Cell phone usage during the day. Over here we have no cell phone at night, no cell phone during the day, and then using the cell phone at night. 4 different conditions. Down here, we have a 4x2 factorial design. So again, that's saying that we have two independent variables, but one of them has 4 conditions as opposed to what we've been dealing with up to this point with 3, or with 2. And then the other independent variable in this has 2. So we have time with its 4 conditions as independent variable number 1, and the type of therapy as independent variable number 2. And our dependent variable, as indicated by the y-axis over here, is the number of symptoms that participants are displaying. So we have our time with its 4 conditions on the x-axis. Excuse me, you see 2, 4, 6, and 8. Excuse me, I have the hiccups. And 8 weeks. And then we have the other independent variable of the type of therapy as type A and type B as the different colored lines and, well, different pattern of lines as well over here. So we have, since it's a 4x2 factorial design, we know that we have 8 total conditions. And basically each dot or square, depending on which line you're looking at, indicates a different condition. So here we are at 2 weeks with type A displaying 12 symptoms and type B therapy type displaying 10 symptoms. And then 4 weeks, we have type A therapy displaying 10 symptoms, and type B displaying about 9. And you'll see that each week, or each time set of 2, 4, 6, or 8 weeks, we're counting how many symptoms of whatever it is they're taking therapy for, but we're counting the number of symptoms we have, and we're comparing it between the type A therapy and type B therapy. So with factorial design, in order to call it an experiment, all of our independent variables don't necessarily have to be measured. To make it true, to make it an experiment, only one, at least one, has to be manipulated. So we can have one independent variable of gender, of male, female, transgender, female. And then we can have another independent variable of, oh, let's give them a math or an English test. Well, we're not manipulating gender, as we talked about when we discussed quasi-experiments. That's a variable that really can't be manipulated. Same thing with age. If we were to compare young people and older people, or people in their 20s, people in their 30s, people in their 40s, we're not randomly assigning those groups. But so those still can be involved in our factorial design. And to classify it as an experiment, all we have to do is manipulate one variable. So let's say we're looking at gender, we're looking at, male, female, transgender, male. We're looking at age as the second independent variable. So we had 4 conditions for that: male, female, transgender, female. So that's our first independent variable of 4. And then we're looking at age, let's say people in their 20s, people in their 30s, and people in their 40s. So that independent variable has 3 conditions: 20s, 30s, and 40s. Now, it's not an experiment yet because we haven't really manipulated anything, but then let's add on to the 2. Let's have an independent variable with 2 conditions of being given a math test or an English test. That we manipulate. That is on us. We have randomly assigned them to take an English test or a math test, and boom. So we had the 4 conditions of the gender variable of male, female, transgender, female. We had the 3 conditions of the age, people in their 20s, people in their 30s, people in their 40s. And then we had the 2 condition independent variable of you're going to either take a math test or an English test. So the independent variable of test type. Now, how many total conditions are there? Well, 4 with our gender, times 3 with our age, that's 12, times 2 with which type of test they're taking is 24. So that 4x3x2 factorial design would have 24 total conditions. But it would be considered an experiment because even though 2 of our 3 independent variables weren't manipulated, those being age and gender, we did manipulate which type of test they're taking. So boom, it's considered an experiment because at least one of those independent variables were manipulated. We also need to make sure we have either random assignment if it's a between subjects design. So if you're going to be in one condition or the other, participants have an equal chance of being in either. Or for within subjects design, counterbalancing. So they have an equal chance of taking condition 1 first and then condition 2, or condition 2 first and then condition 1. Same probability. But counterbalancing is within subjects design that randomizes the order that participants are exposed to all the conditions that they're going to be exposed to. Okay. So when we have multiple independent variables, and let's say only one is manipulated, just like our gender, age, and test type, the only strong causal claims that we can make would be in regards to the test type. So maybe transgender females in their 30s did super well on the math test. Well, we can't necessarily say, oh, it's because they're transgender, oh, it's because they're in their 30s. It's more so we have to make the causal claims in regards to the test type. More so, you know, oh, well, maybe I forget which one I said, the English or the math, but oh, maybe the math test, maybe it was easier, or, you know, maybe they're just better overall. Maybe our hypothesis was that the math test would be higher, or maybe the English test would be higher. And it's like, oh, well, they kind of threw it for a loop. I wonder why. We can possibly say, oh, well, it could be, you know, could be related to gender and age, but we can't really make any strong causal claims with that statement because we didn't manipulate that. So with the results of a factorial design, we have multivariate statistical tests, multivariate studies that we're looking at with multiple independent variables. We have different options. So we have main effect and interaction. Now, when we talk about main effect, we've pretty much been talking about main effect up to this point. That's when we're only looking at one independent variable and its relationship to the dependent variable. So, oh, we give just one independent variable, ignore everything else. Oh, we're comparing people's exam scores on a loud test and a quiet test, or in a loud room and a quiet room. People perform better in the quiet room than they did the loud room. It's only one independent variable and it's two conditions, and we're looking at the effect of the dependent variable. So people who took the exam in a quiet room had higher exam scores compared to those in the loud room. Well, that's a main effect. We're only looking at one independent variable, and in this one we have two conditions. They did better in the quiet condition than they did the loud condition. We've been pretty much doing main effects up to this point. We just really haven't been calling it main effects. We've just been saying, oh, you know, it's statistically significant, or oh, just the quiet room performed better. And that's due to, it's because of the quiet nature of the room, since we manipulated that, and we can make causal claims with, oh, they performed better because the room was quiet, they had less distractions or what have you in comparison to the loud room. Now with interactions can only occur when we have more than one independent variable. So we've had multiple examples of more than one independent variable. The excuse me, the time period and the type of therapy that people received, that was a multi-independent variables test or study. The cell phone usage and the time of day, that was a multi-independent variable study. But with interactions, it's not as simple and cut and dry as, oh, one independent variable, one condition did better than the other. With interactions, since we have all these different conditions, you know, we have at least four with a basic 2x2 factorial design, two independent variables with two conditions each. Interactions would say, oh, people that you know, one condition or one independent variable, one condition of one of the independent variables kind of influences the other independent variables and how they work. So what I mean by that is, let's say we're looking at the cell phone usage and the time of day that you're driving, and we're looking at your driving performance. An interaction would say, oh, well, no cell phone usage, or the time of day really dictated. There was a big difference between the time of day, day or night, and the no cell phone usage. So at night, people, without using it, when they did not use their cell phone, they performed a lot better at day than they did at night. One condition of the independent variable. hold on. Okay, back to where we left off. Okay, so like I said, main effects, what we've been looking at this point, we're just looking at one independent variable and we're comparing the conditions. We're comparing the dependent variable scores or stats or however you're measuring that dependent variable. We're comparing those across the conditions of our one independent variable. Main effect is always going to happen when we have one independent variable. So we see here an example, a graphed example of what a main effect looks like. We have one independent variable of the noisy or the quiet room condition for the exam. And we see that there's a stark difference with the quiet room scoring a lot higher on the test than the noisy room. That's apparent. That's a main effect. Now, interactions, we can only have an interaction if we have more than one independent variable. So if I'm going to ask a question as to like, oh, is this a main effect or an interaction on an exam, let's say, or something like that, whenever you see more than one independent variable, there's a chance that it's going to be interaction. There's no chance of there being an interaction if there's only one independent variable. Okay, so let's look at what those look like when they're being graphed. So we have the test type of English and math, and we have, again, the room condition of noisy and quiet. So we'll see that the noisy condition pretty much scored the same in both terms. So for the English test and the math test, the noisy condition stayed right at 4. That didn't change. However, when we look at the quiet condition, the blue bar, we'll see that when the room was quiet, the English test takers scored a lot higher than the math. So that's saying that one condition of one of our independent variables, the English test, or the English test out of the test type independent variables, was impacted by the room condition, so the quiet condition of the rooms. Whereas the math test, that didn't matter. The math test was unaffected either way. It stayed pretty much right here at 4, but one condition was changed for the other. So in our English condition, the quiet room condition shot up. They scored the best. Excuse me. So the condition of the quiet room was stronger for English takers than math test takers. You'll see that, again, it's one of the conditions of the quiet room, and we'll see that it shot up for one of the other conditions. Over here at math, they're pretty similar, the two test scores, regardless of the room they were in. But here with the English test, there's a stark difference. So we'll see here what's known as a crossover interaction. These are just some different examples of interactions. I'm not going to necessarily test you on each of these different types of interactions. I'm just giving you some visual and some idea of what they could be and what they look like. So we'll see here, again, we have our different test types. We have English and math, and we have the noisy room and the quiet room, noisy being the greenish bar, quiet being the bluish bar. We'll see that the quiet room, again, the blue, has an effect for English and for math, but in opposite directions. So here in the English room, we'll see that the noisy, they did poorly, the quiet, they did very well. But in math condition, it's flipped to where the noisy, they do super well, and the quiet, they don't do very well. So that's a crossover interaction when they kind of have that, when they have an effect, but in opposite directions. So for the quiet condition of our noisy, or of our room condition of the quiet or noisy conditions, we'll see that for one independent variable, or one condition of the test type, English, quiet, super good, noisy, not so good. And then for the other condition of our test type, English, now we're going over to math, the noisy condition, super good, and the quiet condition, not so much. So it's flipped. So With interactions, again, they're only possible if we have more than one independent variable. If we just completely ignore, if we gave everyone the English test and the only thing that we're looking at was the noisy and quiet conditions, those were the only things that we manipulated, because if the English test is the same for all conditions, so it's not an independent variable. If we only gave the English test and only tested on the noisy and quiet conditions, we would have a main effect here, because we'll see that for the English test, noisy performed a lot more poorly. They didn't perform as well as the quiet condition. Again, main effect. If we ignore the math test, if we did not give a math test and only gave an English test, we would see that as a main effect. But since we have two independent variables of the room condition, noisy or quiet, and the test type, English or math, now we introduce the possibility of interactions, and we see an interaction here. Again, this is known as a crossover interaction, where the quiet room does have an effect for English and math, but in opposite directions. Same thing for the noisy room, opposite directions. Again, you can kind of look over these interaction graphs and see pretty much when one of these bars is way higher than the other, there's probably an interaction going if there's more than more than one independent variable. So that is our main effect and interaction and factorial design lecture. If you have any questions, keep in mind I still have my office hours going, even though we have passed our first exam. My office hours are still available for you to attend and ask questions and get clarifications if need be. But that's all I got for you. So have a good week and like and subscribe.